Let's start with the chapter straight lines. Now we'll start with basics as to what you have learnt already, and then we'll move on to the straight lines. Fair enough? Now, in this particular chapter, what we are talking about is straight lines, isn't it? Now, in the first basic part, what we have is the distance between the 2 points in the Cartesian plane. Now, in the Cartesian plane, you have the x and y axis, and you have 2 points. Say this point is A, say this point is B. Fair enough? Say the point A is given to be x1, y1, and point B is x2, y2. So there are 2 points A and B. The distance between the 2 points. So here suppose say this is the distance between the 2 points, and the formula for the distance between the 2 points AB is equal to root of x2 minus x1 whole square plus y2 minus y1 whole square. Basically, the difference in the abscissa square plus the difference in the ordinate square. This gives us the distance between the 2 points, wherever it is and however the orientation of the point might be. This gives the distance between the 2 points. Now, after finding the distance between the 2 points, then we have section formula. Now, you have learned section formula also. Section formula basically talks about, suppose if the line joining the 2 points is divided in some ratio. That means suppose say we have 2 points AB, and these two points, basically the line joining the 2 points is divided by some point P, where here again A is x1 y1, B is x2 y2. Say this is M is to N. Then the division between AB, the point P, the coordinates of point P. So this is given by mx2 plus nx1 divided by m plus n. This is for the abscissa. For the ordinate, my2 plus ny1 divided by m plus n. This gives the abscissa and the ordinate of the point of division. P is called as the point of division. And including the same thing, suppose if P is the midpoint, then generally the midpoint is given by m is equal to x1 plus x2 by 2, comma y1 plus y2 divided by 2. This is the midpoint between the two given points. Correct? This also you have learned last year. Now, there is one more concept, which is the area of the triangle. That means here, suppose say we are looking at the, say here, see you have AB. Suppose say you have a point C here itself. And we are going to join this, and we are going to make this into a triangle. That means what we have here, you have a triangle. This is the triangle. ABC is the triangle. Now here C will have a coordinate of x3, y3. Then area of the triangle. So we can write area of triangle ABC is given by delta is equal to half into mod of x1 into y2 minus y3 plus x2 into this. It keeps on going. So generally what we write here is that instead of writing this whole thing, we can write in the form of sigma. That makes more sense. So we can write half modulus of sigma x1 into y2 minus y3, where I is equal to, so here you can write xi, you can write like that also, or you can write like that also, or you can just keep it as it is. So that means we can just write sigma x1 into y2 minus y3. This is basically whatever you have learned so far. Now we'll start say with this particular prerequisites as to what is a midpoint, what is section, what is distance formula and area and everything. Now we'll look into the next part, that is the beginning of the chapter, to understand about straight lines in the Cartesian plane. Whenever we understand straight lines or whenever we look into a straight line, you need to understand a very important parameter in a straight line. That is the slope of a straight line. So first let's try to understand what is a slope. Okay, now here, suppose say you have the x and y axis. This is the origin. Fair enough. Suppose say a line goes something like this. So assume that this is a line. Now this particular line makes an angle of theta with the x-axis, correct? Now there are two values. With respect to x-axis only, there are two angles. So if this angle is theta, then the other angle, what you can call it, the other angle is going to become 180 minus theta, correct? So you have two angles. Now, what we are looking at is the angle theta, because if you look at any angle or between any two lines, if you are trying to understand the angle is always measured in anti-clockwise direction. This is like a general rule in math. That means any anti-clockwise angle, it is considered to be positive. Fair enough? Like even if you take an example of this, we say this is angle, some angle 30 degree, 40, whatever it is. It is the anti-clockwise angle, correct? And we never say, okay, this is the angle between the two lines. No, we call it as the reflex angle. But whenever two lines are given, it's always the anti-clockwise where the angle is considered to be positive. That is the general rule, or you can say it's a general norm in which the angles are measured. Fair enough? Now, what we are looking at an angle theta in this particular figure. When you look at angle theta, what you need to understand is that suppose if the value of theta changes, okay, suppose that means here, let's assume that in this case, say theta is the value theta 1, let's take it as theta 1 in the first case. Say theta 1 is equal to 40 degree. The line is in a particular orientation with respect to x-axis, correct? Suppose if the theta value changes to 60 degree, then what happens? The same line changes the orientation, correct? So the same line will change to something like this. The orientation changes. That means here, if the value of theta is changing, the gradient of the line is changing, correct? That means either it is very flat or it is very steep. Makes sense? It's like you have a flat hill and you have a very steep hill. Everything depends on the gradient, isn't it? Now, even for a line also, that gradient is a very important parameter. And that gradient or that parameter which defines the gradient of the line, that basically is what we call as slope. So slope is nothing but the gradient of the line. How steep or how flat the particular line is. If the slope is very high, then the gradient is very high. If the slope is very low, then the gradient is very low. Fair enough? So the next point is, how do we mathematically define it? Because one way of understanding the slope is, it's just a gradient, very easy to understand. But how do we define it mathematically? This is the next point. To define it in a mathematical way, we use trigonometry to understand this one. Okay, so by the mathematical definition of a slope, it can be defined as the ratio of the difference in the ordinate to the difference in the abscissa. This is the formal definition of a slope. Now let's try to understand how we get this definition and what we mean by the difference in the ratio, and a lot of other mathematical terms are there. Now let's try to understand the actual definition of a slope. Now let's assume that we have 2 points in the Cartesian plane. Fair enough. Let's assume that we have x-axis and y-axis here. Say we have 2 points. Let's assume this is 1 point, say this is one more point. Say this is A, say this is B. Now here, suppose say I join AB and we extend this backwards. See, when you extend this backwards, what's going to happen? This value is theta, correct? Now from A, we write one line parallel like this. From B, we write one more line parallel. Parallel to what? X and Y axis. That means even this value will also be theta. Make sense? Now generally B coordinate is x2 comma y2 and A coordinate is x1 comma y1. Now what I want you to understand is that suppose say this point is C. Now what will be AC distance? AC distance is going to become x2 minus x1. Same way BC distance becomes y2 minus y1. Now this one I want you guys to understand the same logic what you used last year in understanding the distance formula. Because here from O to B is going to be x2, correct? So when you draw a perpendicular, all those things, you guys have done that before. So it's just the same thing. So AC becomes x2 minus x1 and BC becomes y2 minus y1. Now in this, let's see what is tan theta. In the sense, in triangle ABC, tan theta is equal to what? BC divided by AC. Correct? So BC is what? Y2 minus Y1 divided by X2 minus X1. Now remember, tan theta is nothing but the slope of this particular line. So slope of the line is represented by M. So M is equal to change in the value of Y. So we can write Y2 minus Y1 by X2 minus X1, or you can also write this as delta Y by delta X. This basically is the definition of a slope. Okay. Now in the next video, we'll do few more concepts of the slope. Now once you have understood that, like, yeah, difference in ordinate and difference in abscissa is going to give us slope, we'll understand more about slope and how the orientation of the straight line changes with respect to slope in the next video.